This is Dr. R. Obulakonda Reddy, Department of CSC Cybersecurity. In this session, we discuss about the introduction to grid and its evaluation in a second generation. Now, majorly in a grid evaluations, integrated systems. Mainly, we observe that integrated systems are key role play in a second generation at a grid. Now, at the second generation, grid components emerged. A number of international groups started with the projects that integrated these components into coherent systems. And the other thing is, these projects were dedicated to a number of exemplar high performance wide area applications. It is provided with high performance wide area applications. These sections discussed with the representative of these projects are, the project are Cactus, Data Grid, Unicore, Webflow. These are all the major components play in a grid at second generation, evaluation of grid at second generation. Now, one by one we discuss that. Cactus. What is the Cactus? So, Cactus is an open source, it is a problem solving environment designated for scientists and engineers. And this one is one of modular structure that enable the execution of a parallel applications across the range of architectures and the collaborative code. This is the major thing, parallel applications across a range of architectures and the collaborative code development between distributed groups. And next thing is Cactus. It is organized in the academic research community, where it was developed by a large international collaboration of physics and computational scientists for black hole simulations. And second thing is a data grid. This is the European Data Grid project led by IARE. It is founded by the European Union with the aim of the setting up a computational and data intensive grid of resources for the analysis of data coming from scientist explorations. So, data grid, it has to provide it with a SEN. This project has to be by SEN. It is a European Union with the aim of the setting of a computational and data intensive grid of resources for the analysis of data coming from the scientific explorations. And other thing is that the primary driving application for the data grid project is the Large Hadron Collider, LHC, and which will operate under the CERN from about 2005 to 2015 and represent a leap forward in practical beam energy, density, collision frequency. This leap is necessary in order to produce some examples of previous undesired practicals, such as the Higgs boson or perhaps super systematic quarks and the leptons. The main objective of data grid projects are to implement the fabric and the grid management, including it has to be evaluation, testing, integration of existing middleware, and research development of a new software as appropriate. And to deploy a large scale test bed, and second thing is to provide production quality demonstrations. The data grid built on top of Globus include the following components. The first thing is a JDL, job description language. It is a script to describe the job parameters. It has a script that has to be described with the job parameters. And the second thing is a user interface, UI. It has sent the jobs to the RB and receive the results. What is the RB? It is a resource broker. So now the RB is resource broker, locate and select the target computing element, C. Locate and selecting the target component element. And other thing is the job submission services, JSS. This is submit the job to the target C. C is a computing element. And next one is L and B, logging and bookkeeping. So this is record job status information. This is records job status information which has to maintain with a logging and bookkeeping. And next thing is the grid information service, GIS, information index about state of the grid fabric. And next thing is replica catalog. So this is a list of data sets and they duplicate held on storage elements, SC, storage elements. It has maintained with the data sets and they duplicates held on storage elements. So these all will hold at a data grid at globus and top of the globus and include these components. And the next thing is the Unicode. So Unicode is the full form is Uniform Interface to Computer Resources. That's the name Unicode. It is one of the project founded by the Germany Minister of Education and Researches. Uniform Interface of Computer Resources. Unicode. So the goal of this Unicode includes uniform and easy to use GUI, graphical user interfaces, and open architecture based on the concept of abstract job. It consists of security. It has consists of a security architecture, minimal interference with local administrative procedures, exploration of existing and emerging technologies through standard Java and web technologies. So emerging technology through standard Java and web technologies. And Unicode provides with a interface for job preparation and secure submission to distributed supercomputer resources. What is the main Unicode components are job preparation agent, JBA, and the job monitor controller, JMC. And next thing is a Unicode HTTP server, also called as a gateway. Unicode HTTP server, also called as a gateway. The network job supervisor, NJS, and Java applet based JA with online help and assistance facilities. These are all the components which is provided at Unicode. JPA, JMC, and gateway, NJS, network job supervisor, and Java applet based GUI, which is with an online help and assistant facilities. And next thing is the web flow. This is the another type of the second generation of grid evaluation. Next, web flow. It is a computational extension of the web model that can act as a framework for wide area distributed computing. It is designed. It is act as like a framework for wide area distributed computing. Now, the main design goal of the web flow was to build with a seamless framework for publishing and resuming computation models on the web. In a web, it has to be a framework, for publishing and reusing computational modules in the web. So that it has to be easy for end users via web browser, can engage the composing distributed application using webflow models. As usual, components and editors as usual, authoring tools. As visual components and editors as visual authoring tools. Next, webflow has a three-tier Java-based architecture that could be considered with a visual data flow systems. Another thing is a front-end uses applet for authoring, front-end authoring, visualization and control of the environment. These are all the three parameters we have observed at a front-end. And webflow uses servlet-based middleware layer which has managed and interact with a back-end modules such as legacy cores for databases or high performance simulations. Now coming to the summary experiences about the second generation at a grid evaluation. Now in the second generation, the core software for the grid as evaluated from that provided by the early vanguard offerings such as Globus, GT1 and Lazier, which were dedicated to the provision of property services to large and computationally intensive high performance applications through to the more generic and open development of Globus, G22 and Avaki. Along this core software, the second generation also saw the development of range of accompanying tools and utilities which were developed to provide higher level services to both user and applications, which was provided with a tools and utilities, which is high level services to the both user and as well as the applications. And the span resources scheduler and brokes as well as the domestic specific user interfaces and the portals. P2P techniques have also engaged during this period. This is some overview about the second generation grid evaluation. In the second generation provided the interoperability that was essential to the achieve large scale computations. Interoperability that was essential to achieve large scale computations. As further grid simulations, grid solutions were explored, other aspect of the engineering of grid become apparent. In order to build a new grid applications, it was desirable to be reuse existing components and information resources, and to assemble these components in a flexible manner. The solutions involved increasing adaptation of service-oriented model and increasing attention to metadata. These are the two characteristics of third generation systems: a service-oriented model and increasing attention to metadata. These are all solutions. We have to more solutions: increasing adaptation of service-oriented model and increasing attention to metadata. This will be more focused on third generation systems. Now I collect data from these textbooks.
Like, share and subscribe. Hit the bell icon for more updates.